In the last lecture, we had studied about the empirical formula and the molecular formula. So now we will start with the discussion of stoichiometry. So we will start the discussion of stoichiometry now. So stoichiometry is the proportional relationship between two or more substances during a chemical reaction. The proportional relationship between two or more substances during a chemical reaction. Okay. So what happens that stoichiometry represents the exact mass or moles of reactants which are required for the reaction or the mass or moles of the product that are formed. So stoichiometry represents the exact mass or moles of the reactants which are required to react with each other without any wastage, okay, in such a way that all the reactants are consumed completely and also finds out the exact mass or moles of the product which will be formed. Okay. So stoichiometry represents the exact mass or moles of the reactants as well as the products. Okay. So for example, we have this reaction. Okay. So in this reaction, what happens? We find out a lot of informations from this reaction equation. Okay. What are the informations? First of all, we understand the gaseous reactants and products. G represents gases. Okay. Similarly, if any of the reactant or product is solid or liquid, we will write like this: S for solid and L for liquid. Sometimes the gases are also represented with the upward arrow. Okay. So in this reaction, these coefficients, that is how many methanes are reacting in this reaction. So number of methane in this reaction is 1. Okay. How many oxygen are reacting? This is 2. Okay. So these are the coefficients of reactants. Similarly, how many carbon dioxide is formed? The answer will be 1. How many water are formed? This is 2. So these are called stoichiometric coefficients. Stoichiometric coefficients. So basically stoichiometric coefficients represent how many moles or how many molecules of the reactants are involved in the reaction and how many moles or molecules of the product are formed. So they represent the number of molecules or moles taking part in the reaction or formed in the reaction. We can talk about this reaction in 2 ways depending on the stoichiometry. Okay, so the first one is we can talk about it in terms of moles. So we can say that 1 mole of methane reacts with 2 moles of oxygen gases, okay, to give 1 mole of carbon dioxide and 2 moles of water vapor. Okay. Also we can say that 1 molecule of methane reacts with 2 molecules of oxygen to give 1 molecule of carbon dioxide and 2 molecules of water vapor. Okay. Now, we had seen that at STP, 1 mole of each gas, 1 mole of every gas has a volume of 22.4 liters. So, we can say that the volume of methane here is 22.4 liter. So, volume of oxygen will be 2 into 22.4, that is 44.8. Similarly, we can write that at STP, 22.4 liters of methane, these are all gases, reacts with 44.8 liters of oxygen to give 22.4 liters of carbon dioxide and 44.8 liters of water. Okay. So, this is how stoichiometry helps us. Now, we will understand stoichiometry in a better way by solving some examples. Okay. So, the first question is, calculate the amount of water vapor produced by the combustion of 16 grams of methane. Okay. So, let's write the combustion of methane once more. This is the reaction. Okay. So, we have to find out the amount of water vapor that is produced by the combustion of 16 grams of methane. So, let's find out the molecular weight of methane. This is equal to 12 plus 1 into 4, that is 16 AMU. Okay. So, the molar mass of methane is equal to 16 grams. So, what does it mean? That 1 mole of methane weighs 16 grams, right? Now, 1 mole of methane forms 2 moles of water. 1 mole of methane forms 2 moles of water. Okay. So, how much does 1 mole of water weigh? 1 mole of water weighs, this is the molecular mass of water in grams, or molar mass of water. So, this is equal to 2 into 1 plus 16. So, 18 grams. Okay. So, 1 mole of water weighs 18 grams. Now, 1 mole of methane forms 2 moles of hydrogen. So, 2 moles of water weigh 2 into 18, that is 36 grams. Okay. Let's see one more question related to this reaction. How many moles of methane is required to produce 22 grams of carbon dioxide? Okay. How many moles of methane is required to produce 22 grams of carbon dioxide? So, 1 mole of methane forms 1 mole of carbon dioxide. So, 1 mole of carbon dioxide is formed from 1 mole of methane. Okay. So, how many moles is 22 grams? So, molar mass of CO2 is equal to 12 plus 16 into 2. This is equal to 44 grams. Okay. So, 44 grams of CO2 is equal to 1 mole of CO2. So, 1 gram of CO2 is equal to 1 by 44 moles of CO2. So, 22 grams of CO2 is equal to 22 divided by 4, that is 0.5 moles of CO2. Fine. So, how many moles of methane is required to produce 22 grams of carbon dioxide? Now, if 1 mole of CO2 is formed from 1 mole of methane, then 0.5 moles of CO2 is formed from 0.5 moles of methane. Okay. So, this information is obtained from stoichiometry. We will see one last example from stoichiometry. Calculate the mass of slacked lime required to decompose 4 grams of ammonium chloride. Calculate the mass of ammonia formed. Okay, and the reaction is given as okay. So, calculate the mass of slacked lime. Slacked lime is calcium hydroxide required to decompose 4 grams of ammonium chloride. Calculate the mass of ammonia that is formed. So, 1 mole of calcium hydroxide reacts with 2 moles of ammonium chloride to form 1 mole of calcium chloride, 2 moles of ammonia and 2 moles of water. Okay. Now, molecular weight of calcium hydroxide is 74 grams. Molecular weight of ammonia is 53.5 grams multiplied with 2, so 107 grams. Molecular weight of calcium chloride is 111 grams. Molecular weight of ammonia is 34, so multiplied by 2 we get, molecular weight of ammonia is 17, multiplied with 2 we get 34 grams. Molecular weight of water is 18, so 2 moles means 36 grams. Okay. So, this is the masses of these reactants and products. So, 107 grams of ammonium chloride reacts with 74 grams of calcium hydroxide. So, 4 grams of ammonium chloride will react with 74 by 107 into 4 grams of calcium hydroxide. So, this comes as 2.766 grams of calcium hydroxide. Okay, and calculate the mass of ammonia formed. So, 107 grams of ammonium chloride forms 34 grams of ammonia. So, 4 grams of ammonium chloride will form 34 by 107 into 4 grams of ammonia. So, this comes as 1.27 grams of ammonia. So, we have studied about stoichiometric calculations. In the next lecture, we will start about the balancing of reactions with the help of stoichiometry, and we will learn about limiting reagent. Thank you.